And now, ladies and gentlemen, Executive Director of the Office of Technology Licensing at Stanford University, Ms. Katherine Ku. Let's give her another big warm welcome. She makes her way on stage.
Thank you. So I'm pretty informal, and you can ask me any questions.
What kind of things that, if you could go back 40 years ago and you would change?
So I wasn't there the whole 47 years. But I actually joined Stanford right when the government changed the law for universities to take title to inventions. So I grew up in the office, sort of. I had worked in industry prior, and so again, I had some experience in industry, and actually when I worked in industry, I had filed a patent, so I sort of knew a little bit about patents. So again, Stanford's technology licensing office was very small. When I first started, there were 3 of us that were professionals. And that was around 1982 that I started in that office. When I first went to the University Professional Society meeting, now you know it as AUTUM, Association of University Technology Managers. It used to be called SUPA, Society of University Patent Administrators. That meeting had about 70 people. That was really, in 1980, 70 people. Now, if you go, it's 1,000 people. So again, we were one of the very early offices. Our first director was entrepreneurial at Stanford, and he thought it would be really interesting to see what we could do with the inventions that came out of Stanford. So he started the office with basically 2 people. So again, you can start small and then grow. So then when I joined, it was 3 professionals and just 2 administrative people. And we grew as we got more volume and as we were more successful. So I was lucky to be able to handle this Cohen-Boyer patent, the recombinant DNA patent. And honestly, I was basically a scientist type person. And we didn't have our systems in place. We were still a very small office. And we had signed up about 73 companies to take this license for the Cohen-Boyer patent. Now, we didn't have any invoicing, and the deal with the license agreement was they would pay us $10,000, and then in 3 months, they would pay us another $10,000. Well, we never sent out bills for the second $10,000, and nobody paid. So my job was to call all these companies and say, you owe us $10,000. That was the hardest job ever. I mean, I was sort of shy, to call a company and say, you owe us $10,000 is not fun. But I learned to do that, and now I can call anybody and really feel very comfortable about calling any stranger. So it's good training, but it was really hard. So again, my first deal that I ever did was something like $5,000 up front. One of the things that we did in the early years is we didn't ask for much diligence. Diligence is that the licensee will really develop the technology, promise to develop it. We had just a clause that said, licensee will be diligently developing, but we didn't have any timeline or description of how they would develop it. And over years, we've really learned that you have to say, in 2 years you're going to do this, in 4 years you're going to do that. It's not the university imposing a deadline on these people. You talk it together. If the company thinks it's going to be 4 years, then we actually tell them to make it generous, because most companies don't make their timelines. It actually takes longer than they think, even when they're very generous. But nowadays, we ensure that there's some diligence, because the worst thing is for a company to sit on the technology. We had one case where we had several bidders on some technology, and in that case, we decided to go with the company that was the highest bidder. So for us at the time, $50,000 was a lot of money, versus everybody was offering $5,000, everybody else. So we went with the $50,000 company. Well, what they did was nothing. They sat on it for 3 years, and then they terminated the license. So that means we lost the opportunity to transfer that technology. It went nowhere. So that's why I say don't just go for the money. The one who pays the most sometimes will just sit on it so that the competitors won't take it. So again, you have to look a little deeper than just how much they're going to pay. I feel like at the end of the day, I said that we get more money from the earned royalties. So again, many universities, because they feel like there's a pressure to bring in money, they'll want to charge a lot at the beginning. Well, as I told you, the technology's early. It's very risky. If you make them pay a lot at the beginning, they're not going to be able to afford it. So have them pay maybe more as the technology proves to work, and then at the end, if you pay an earned royalty, a percentage of sales, that is probably a win-win for both parties. I do think, growing slowly is the best way, because otherwise you have too many ambitions, and then the higher ups all keep asking you, what did you do? What did you do, for us today? What money did you bring in? So again, I really believe in managing expectations. Don't tell your bosses you're going to bring in a lot of money. Be very conservative. Forecast conservatively and keep them informed. And the more you keep them informed, the more they realize how complicated it is. That the decisions you have to make are not easy decisions. And then they will be a lot more understanding of the kinds of decisions and why you make them in the future. And also, they'll be much more supportive. If some faculty is critical of your office for not doing what they wanted you to do, if you have a good reason why you didn't, that's much better than just having them complain. And again, I always warn my boss if there's going to be a potential problem. So I always work very closely with my leadership.
It's more of a lot of your support base has been through the private companies. A lot of the support comes from private companies. On a policy platform, how much of policy makers, how much help do you get from policymakers, and what can Thai policymakers do, or what can countries in this region do in order to promote this tech transfer from universities to the masses? Thank you.
Well, even in the US, we're still trying to improve, and the policymakers at the government level want to increase what they call the return on investment of federal research dollars. The policymakers, I feel that you have to be very thoughtful about making policy. My particular view is not to micromanage the local people, the local offices. So in the US, the federal government gave the universities the right to take title to inventions. And then they basically leave us alone. They want us to report the inventions so that they know how many inventions are coming out of their research. And we tell them if we license it. But they don't come in and say, well, why didn't you bring in more money? Or why aren't you doing more licenses? Because they trust that at the local level, we're going to try to do the best we can. And I really believe that being the people at the local level, you who are working with the faculty, you can make the best decisions for your university. And so I think that the policymakers shouldn't try to put in too many regulations to manage this. The policy people also need to think very carefully about metrics. People will always try to meet the metrics. And if they're not realistic, you can really skew the whole system. And again, I'm a little bit familiar with China. The Chinese government told the universities, you shall file patents. So they all filed thousands of patents. And they have lots and lots of patents. And so their numbers look really great. And then one person came to me and said, we have so many patents, but we don't know what to do with them. So really, it doesn't matter if you have thousands and thousands of patents. If you're not transferring them to the private sector, there's no point. So I don't believe in counting patents. I do believe, again, it's a little bit of a hard metric, the number of licenses that you do. But if you don't have many invention disclosures, you're probably not going to be able to do many licenses. Because I do believe there's a critical mass. You need to see a bunch of inventions to have some successes. If you're only going to see 10 a year, it's probably not enough. You know, my numbers are terrible. 3 or 4 big winners out of 12,000 inventions. Now, many other inventions make much less money. It's not to say that that's all there is. But there's many, many inventions that make $20,000, $30,000. That's perfectly fine, because that's a base. You're going to have a base of those kinds of inventions.
Sorry. Okay. I'm from the private sector. Just like to ask you, since you are small, as you said, well, you're big for us anyway, but then you probably have a lot of inventors coming in your line. How you select which one could be the first priority that you would work on with? Is there any factors that you judge on each of inventors that you have? Which one it should be more valuable in terms of the commercialization than others?
That's a very, very hard question, which is why I said evaluation is probably the hardest thing, and probably the essence of what we do, because there are so many inventions. Now again, because our office was so old, we had experience with inventors. When we were small, and I do think meeting with the inventors personally is really useful. You will find certain kinds of researchers are very innovative, and they will invent and invent and invent. Now again, we have some inventors who invent and invent and invent, but they're small inventions, and they don't get licensed because they're small improvements. And then we have some inventors who only come to us when they have what they think is a good invention. And we, from experience, know that their technologies will attract the attention of industry because their name is good and because people believe in their science. And then we will probably invest in that person. Now, of course, the one we don't know about is the young, new faculty who come in. Are they going to be which kind of inventor? So I think you have to assess, and you meet with them, and many times you take a chance on them. And then they learn how the process works, and maybe their invention gets licensed, and maybe it doesn't. But as they get more experienced, and you get more experience working with that inventor, you will have a better sense. Now, the way our office is structured, it's a pretty big office for tech transfer, is people by discipline. We had electrical engineer, we have mechanical engineer, we have bio people, etc. And so when the invention comes in a particular topic, we give it to the person who's more likely to understand that invention. And over years, they really will have a sense of new inventions and whether something is patentable or licensable. Now again, our experience is it's much harder to license in the physical sciences, actual devices. The semiconductor industry is hard to license into. Again, the physical science IT companies, they believe in lots and lots of patents, and they do cross-licensing with each other. So, each computer has, 500,000 patents in them. And Intel really doesn't want to take one license for one patent from a university. And most of the times they don't really want to pay anything, because even if you charge per chip, it has to be so low. And they don't want to count like that. So with big companies and technologies like that, typically we'll charge a yearly fee, some fee, so we know that they took a license. We want them to take a license and then pay us something, but it's too hard for both sides to keep track on sales numbers like that. Biotech and life sciences, very, very different. They believe in patent protection to protect, and they only have maybe a few patents on their products. So they will willingly pay and earn royalty because the chance of having a sale is much riskier. So we know the development time is really long, but if they finally get a product to the marketplace, they're willing to pay an earned royalty. So again, you have to know the kind of industry you're dealing with in order to set the financial terms appropriately for that industry.
In Thailand, we don't have a Bayh-Dole Act.
Yes.
And from your experience, how Bayh-Dole Act help your university to license more of the patent?
I actually very much believe in the Bayh-Dole Act. And I think you can do technology transfer even without it. But I think what it did was make everything more uniform. And it encouraged universities to do this technology transfer thing. And it didn't make who owns this. Is it the federal government? Is it the university? Is it the inventor? Those kinds of questions don't really happen anymore. If you don't have some legislation, then you have to look to the university to set a policy. Now, as our friend from Cambridge talked about, there is this thing called professor's privilege, particularly in Europe, where the professor can keep the invention. Now, if the professor keeps the invention and licenses it to someone, then the professor gets the experience, and they learn how to deal with industry, but they don't share their knowledge with other people. What I think Bayh-Dole did was professionalize our activity. Now we all share best practices in the US. We have an organization where we educate each other. People are coming into the profession, people are going out of the profession, and over the years, we've risen. Our expertise has risen together as a country. So again, I think if you can, it would be a good idea to have a Bayh-Dole. But if you don't have a Bayh-Dole and you still want to collaborate with each other, make an organization of Thai University Tech Transfer people and meet regularly and share best practices. And so you can do a lot without the regulatory framework or the laws, because you're not competing with each other. You all have different technologies. You have different ecosystems in your own university. Teach each other and compare notes. When the three of us get together, we all have the same problems. We all have to deal with inventors. We all have to deal with inventions that don't go anywhere. And we have a budget to deal with. And we just talk about what we do and share with each other. And so then everybody can learn. That's why I think the Bayh-Dole was good, because we made it a profession.
I'm just wondering, how do you handle conflict of interest? Especially, right now, I think Thailand has so many schemes to encourage the inventor and the professor to become a startup. And when it comes to the negotiation, it's rather hard because of, the inventor itself is the one who actually have the knowledge of that. So if you can share that, would be great.
So conflict of interest is a very important topic, especially for the US universities. And again, they have different policies in the universities because, again, they're trying to encourage startups. So every university has to figure out what line they're comfortable having. Some universities really want their professors to do startups, and they will even rent space to the startup. You know, the university will rent space to the startup. At Stanford, we don't do that. We try to keep what we call an arm's length relationship. So at Stanford, because we don't want to just give our faculty the license if they want to do a startup, we feel like we should try to find the best licensee. And it could be already an existing company. Now, so that's why we market all of our technologies broadly. And anybody who is interested in a license can come to our office. As I said, most times there's no response. But let's say there's some technology that's really hot, and several companies are interested in taking a license, including your faculty who wants to do a startup. So then typically we will ask each company to write a sort of a small business plan. It's not 24 pages or 40 pages. It's maybe a two or three page development plan. What would you do with this technology if we gave you the license? And then we try to evaluate that the best we can. Now the startup has the inventor involvement, which is very important. And many times we feel like the inventor involvement is key to making that successful technology transfer. So even if there's an existing company who has all the experience of bringing a product to the marketplace, sometimes they don't really have the passion, right? And they don't care as much. A big company will take on a project, work on it for a few years, and then put it on the shelf. But a startup depends on that technology to do well in order to exist as a company. So that passion is very important to us. So looking at the various development plans, we will make a decision on which company we think will license. And many times we'll decide to license the startup because the inventor is involved and they need to have the know-how. So then the process is that our office will tell another group that we've marketed a technology to X number of companies, and either nobody was interested or somebody was interested, but we chose the startup because of this and this reason. We will write this letter. The faculty will write a letter to describe how are they going to separate their research from the university and the company, and how they're not going to involve the students and their financial interest in the company. And then this conflict of interest person will review this situation and decide whether they think it's manageable or not. If they think it's manageable, then again, we can sign the agreement. So again, there's a very specific process internally. And again, we want to keep the research at the company separated from the research at Stanford. Does that make sense? Yes.
Ornsuri Junshaya from Chulalongkorn University. Thank you for your insightful talk earlier this morning. My question is on helping the inventors realize their research. There are programs such as the Stanford Biodesign Framework, yes, that help push it along. And you mentioned that you like to view your office as more of a business type of office versus a legal one. What role should a university kind of fill to help bridge the gap between really early stage research and then preparing it for something that's ready for commercialization?
Biodesign is a program at Stanford that's really interesting because it's for students. It's basically an educational program. But what they do is teach students to identify usually a medical problem and then come up with a solution. So this is a student course. And so it's what they call needs-based findings. There's a need, then they ask the students to invent a solution. And so this course, they train them how to think about innovation. They actually tell them they must file a patent application as part of the course. And then because it uses university resources, we will own the invention, and it goes through our office. Now, those kinds of inventions are typically hard to license. Medical devices are hard to license to an existing company. If the students want to start a company, then we will license them typically because nobody else is interested. Because again, a new stent, there's lots of stents out there, a new this or that medical device is typically hard to license to an existing medical device company. So again, that course helps the students to figure out what being an entrepreneur means. We have another program for faculty and graduate students. This was started by a faculty member who had started a company, took a leave of absence for a year, went to help run the company, and realized, whoa, academia and company is really different. So she came back to the university and started a program called Spark. It started out very small. We're very good at doing experiments. And if they work, we expand. And if they don't work, they die. So Spark started out very small and actually just for faculty. And she would bring in speakers once a week from the outside to talk about commercialization and drug development. And so, again, you can use your own people. They would talk about regulatory issues. They would bring in someone to talk about patents. They would talk about what is a phase 1 clinical trial, what is a proof of concept, et cetera, et cetera. It's become so popular. I think they celebrated their 15th year anniversary. And now the meetings are huge. They have to have it in an auditorium. And they have researchers come to the meetings, but they also invite outsiders to come and help critique. And different researchers will talk about their project, and then the outsiders, and even insiders too, will say, well, did you think about this? Did you think about that? They all sign confidentiality agreements, so the meeting is confidential. But this also helps the faculty and graduate students to learn about commercialization. Again, sometimes we'll put on seminars for commercialization. I forgot to mention that our two presidents, the last two presidents, have done startups. So our electrical engineering president, John Hennessy, started MIPS, and then that was acquired by Sun Microsystems, I think. Yeah. And he took a leave of absence, and this was when he was a faculty member. So again, our leadership is very involved in commercialization. They do know what this is all about. Our current president is a biotech neuroscientist, and he started a biotech company. So again, he knows at the leadership level, if they understand commercialization, they're going to be much more supportive of it. So again, you have to have up and down the ladder. The leadership has to be very supportive, and then the researchers have to be interested.
Coming back to your theme earlier about metrics and specifically licensing, right? If you were to visualize your process or as a TTO and you look at it as a funnel, and the output of the funnel is the licenses, and one of the inputs to the funnel is disclosures, right?
Right.
But if we were looking for a KPI or a metric somewhere in between, a lever, any levers that you would suggest a TTO looking at to drive the conversion rate to licenses?
Well, I mean, it was an interesting graph when I said more disclosures didn't mean more licenses. But what more disclosures mean is more choice.
Okay.
And so if you see a lot of disclosures, what I view that as is a little bit of an educational opportunity, too, of your faculty. If they're willing to disclose, that means they're willing to engage in the process. And then you can winnow it down. I mean, it still ends up that about 25% are licensed. But as they get experience working with your office, they're going to hone in more on what's going to be licensable or what's useful, what's interesting to industry. So I think if you only have a few disclosures, you don't have many choices. And so then you might invest in all of them, and who knows whether they'll be licensable. Now, it's a mixed bag. Everything we do is a mixed bag, because if you have more disclosures, you're going to have to say no to more people. So you really need to learn how to say no in a nice way, and encouraging them that if only you you know, if you had this more information, we think this disclosure would be licensable. Many times academics don't do that next step, right, to show proof of concept, because they think they have a great idea. But if they can do that one more next step. Now, as tech transfer, we can't make them do that next step, obviously. They have to choose to do the next step. Now, if they choose not to do it and it's not licensed, then they learn that, you know, if they really want to do licensing, they're going to have to move the technology a little bit further. Or they'll have to be involved in a startup. There are many faculty who are frustrated because existing companies are not interested. And so they'll do a startup. And I like the biotech model. They start a small company, develop the technology for several years, and then they partner with a large pharmaceutical company. That's very typical in biotech. And in physical sciences, in the olden days, they would start up a small software company, and then it would be acquired by a large company. So again, they often do acquisitions in the physical sciences, the software companies. You have to know the different sectors too.
First of all, thank you for your very interesting talk this morning. It gives me a lot of practical information that we can learn a lot. By the way, I have one question that TLO, mostly the success of the TLO is how to licensing to the company. So one factor is that you need to have a good network of the company in your hands. Yeah. How can you make that huge network, and how you can keep them good collaboration, good friendship, or whatever? Do you have any tips or tricks or suggestions on that?
Well, that was early on. We would, well, first of all, you can start a database and put names of companies and people from those companies. So that's the first step. Then secondly, you send your people out and go to industry meetings. So for medical imaging, I don't even know what it stands for, RSNA, big meeting. All the medical equipment imaging companies go to those meetings. Or you go to CES, Consumer Electronics Show. You go